Microbes love eating plastic. How scientists found bugs to break down plastic for energy. In March 2016, scientists in Japan published an extraordinary finding. After scooping up some sludge from outside a bottle recycling facility in Osaka, they discovered bacteria which had developed the ability to decompose or eat plastic. Hello and welcome to another video, and today we'll be talking about the latest developments in microbes eating plastics. Since the early 2000s, plastic has become a menace in the world, and we humans have been constantly looking for ways to get rid of the plastic waste that we generate. It finally seems, though, that we are making some strides in getting rid of our plastic waste. Stay tuned and watch the video right till the end, as we have all the details for you in today's video. Before we begin, make sure you like and subscribe to our channel, and also turn on the bell for the latest notifications. Make sure you never miss another video. With that said, let's begin. The bacteria Ideonella sakaiensis was only able to eat a particular kind of plastic called PET, from which bottles are commonly made, and it could not do so nearly fast enough to mitigate the tens of millions of tons of plastic waste that enter the environment every year. Still, this and a series of other breakthroughs in recent years means it could one day be possible to build industrial-scale facilities where enzymes chomp on piles of landfill-bound plastic, or even to spray them on the mountains of plastic that accumulate in the oceans or in rivers. These advances are timely. By vastly increasing our use of single-use plastics, such as masks and takeaway boxes, the COVID-19 pandemic has focused attention on the world's plastic waste crisis. Earth is on track to have as much plastic in the ocean as fish by weight by 2050, according to one estimate. However, experts caution that large-scale commercial use of plastic-eating microorganisms is still years away, while their potential release in the environment, even if practical, could create more issues than it solves. Overcoming an evolutionary barrier. The scientists working to find and develop plastic-eating organisms must contend with a basic reality: evolution. Microbes have had millions of years to learn more to biodegrade organic matter such as fruits and tree bark. They have had barely any time at all to learn to decompose plastics, which did not exist on Earth at any scale between roughly 1950. Seaweed has been around for hundreds of millions of years, so there is a variety of microbes and organisms that can break it down, said Pierre-Yves Patelier, the co-founder of the British company Notpla. That is, using seaweed and other plants to make films and coatings that could replace some types of plastic packaging. By contrast, plastic is very new, he said. Still, recent discoveries of plastic-eating microorganisms show that evolution is already getting to work. A year after the 2016 discovery of Ideonella sakaiensis in Osaka, scientists reported a fungus able to degrade plastic at a waste disposal site in Islamabad, Pakistan. In 2017, a biology student at Reed College in Oregon analyzed samples from an oil site near her home in Houston, Texas, and found they contained plastic-eating bacteria. In March 2020, German scientists discovered strains of bacteria capable of degrading polyurethane plastic after collecting soil from a brittle plastic waste site in Leipzig. In order to make any of these naturally occurring bacteria useful, they must be bioengineered to degrade plastic hundreds or thousands of times faster. Scientists have enjoyed some breakthroughs here too. In 2018, scientists in the UK and US modified bacteria so they could begin breaking down plastic in a matter of days. In October 2020, the process was improved further by combining the two different plastic-eating enzymes that the bacteria produced into one super enzyme. The first large-scale commercial applications are still years away, but within sight. Carbios, a French firm, could break ground in coming months on a demonstration plant that will be able to enzymatically biodegrade PET plastic. This could help companies such as PepsiCo and Nestle, with whom Carbios is partnering, achieve long-standing goals of incorporating large amounts of recycled material back into their products. They have so far failed to succeed because there has never been a way to sufficiently break down plastic back into more fundamental materials. Without new technologies, it's impossible for them to meet their goals. It's just impossible, said Martin Stefan, deputy CEO of Carbios. Besides plastic-eating bacteria, some scientists have speculated that it may be possible to use nanomaterials to decompose plastic into water and carbon dioxide. One 2019 study in the journal Matter demonstrated the use of magnetic spring-like carbon nanotubes to biodegrade microplastics into carbon dioxide and water. the challenges ahead. Even if these new technologies are one day deployed at scale, they would still face major limitations and could even be dangerous, experts caution. Of the 7 major commercial types of plastic, the plastic-eating enzyme at the heart of several of the recent breakthroughs has only been shown to digest 1 PAT. Other plastics such as HDPE used to make harder materials such as shampoo bottles or pipes could prove more difficult to biodegrade using bacteria. Nor are the bacteria able to degrade the plastic all the way back into their core elemental building blocks, including carbon and hydrogen. Instead, they typically break up the polymers out of which plastics are composed back into monomers, which are often useful only to create more plastics. The Carbius facility, for example, is intended only to convert PET plastic back into a feedstock for the creation of more plastics. Even if one day it becomes possible to mass-produce bacteria that can be sprayed into piles of plastic waste, such an approach could be dangerous. Biodegrading the polymers that comprise plastic risks releasing chemical additives that are normally stored up safely inside the undegraded plastic. Others point out that there are potential unknown side effects of releasing genetically engineered microorganisms into nature. Since most likely genetically engineered microorganisms would be needed, they cannot be released and uncontrolled into the environment, said Wolfgang Zimmermann, a scientist at the University of Leipzig who studies biocatalysis. Similar issues constrain the potential use of nanomaterials. Nicole Grober, a nanomaterials scientist at Oxford University, said that the tiny scales involved in nanotechnology mean that widespread use of new materials would add to the problems in ways that could result in yet greater challenges. The best way to beat plastic waste crisis, experts say, is by switching to reusable alternatives, such as not-plus seaweed-derived materials, ensuring that non-recyclable plastic waste ends up in a landfill rather than in the environment, and using biodegradable materials where possible. Judith Enck, a former Regional Environmental Protection Agency (EPA) administrator in the Obama administration and the president of Beyond Plastics, a nonprofit based in Vermont, pointed to the gradual spread of bans on single-use plastics around the world, from India to China, to the EU, UK, and a number of US states, from New York to California. These are signs of progress, she said. Although more and tougher policies are needed, we can't wait for a big breakthrough. And that will be it for today's video on Microbes Love Eating Plastic, how scientists found bugs to break down plastic for energy. What are your thoughts regarding this topic? Let us know your thoughts in the comment section down below, and as always, don't forget to hit like and subscribe to our channel and turn on that post notification bell icon so you'll never miss any amazing videos from us in the future. Thank you and see you in the next video.